Assalamu alaikum. Hope so you are doing great. So in this lab, uh, we will be implementing XOR exclusive OR gate and exclusive NOR gate using NAND gate IC. Okay, so what is a NAND gate? NAND gate is basically AND gate plus NOT gate. So basically the output of AND gate is then passed through a NOT gate so that the output of AND gate is inverted. Main objective of this lab is to differentiate between fundamental and universal gates. Then to prove the universality of NAND gates, and then construct obviously exclusive NOR gate and exclusive OR gate using NAND gate IC. Why this lab specifically like says to make exclusive NOR gate and exclusive OR gate using NAND gate IC? Because NAND gate is called universal gate. And what is a universal gate? Universal gate is the one through which we can make all other gates. And what is fundamental gate? Fundamental gates are those basic gates which are AND, OR and NOT. And obviously from fundamental gates we can also make all other gates as well. But NAND gate is not a fundamental gate, and still we can build all other gates using NAND gate or NAND gate IC. So again, fundamental gates are AND, OR and NOR, basic gates or fundamental gates. Through fundamental gates we can make other gates like NAND gate, NOR gate, exclusive OR gate, exclusive NOR gate, and all others as well, if there are. And why NAND gate is universal gate? Obviously there is another gate as well which is universal gate. I guess so it's NOR gate, you can check it. But so NAND gate is the one through which we can build all other gates. Therefore NAND gate is called universal gate, and therefore we are building XOR gate and XNOR gate using NAND gate IC in this particular lab, which is lab number 12. And obviously third objective is to make the whole circuit physically in the lab to prove obviously that we can make XOR XNOR gate using NAND gate IC. Talking about the universality of the gate, I have already talked about it, but let's revise it. So we can make all the gates using NAND gate, and this is the symbol for NAND gate. So it is an AND gate, D symbol is for the AND gate, and this dot or this hole indicates that there is a NOT gate coupled with the output of AND gate as well. So this is the symbol for NAND gate. Okay, so obviously you would have the idea of what is the output of NAND gate if it is the combination of AND gate and NOT gate. So AND gate only gives 1 when both inputs are 1. And what will NAND gate do? NAND gate will gives 1 or in all the situation except this particular situation in which AND gate was giving 1. Why? Because all the outputs are now inverted through NOT gate. So NAND gate will give 1 on 0 0, it will give 1 on 0 1, it will give 1 on 1 0, but it will give 0 on 1 1. Okay, so let me make the truth table here. So 1 1 it will give 0, 0 1 it will give 1, 1 0 it will give 1, 0 0 it will give 1. So this is the truth table of NAND gate. So we can make a NOT gate by simply combining its both inputs. So when you have combined its both inputs, let's say you have given 1. So what is the situation? 1 is given to the both inputs. So what is the output? So in this case, when both inputs are 1, the output is 0. So when you have given 1 here, you are getting output 0. Similarly, when you are giving 0 here, like you have coupled both the inputs, so you are giving 0 0 on both the inputs, and you will be getting 1. So it is acting as a NOT gate. See, you have made NOT gate using NAND gate. Similarly, if this is a structure for NOT gate, then you can know that you can simply invert the NAND gate to make it AND. Why? Because there was a NOT gate added after the output of AND gate. So if you can add another NOT gate with the output of NAND gate, you can make AND gate as well. So this was your NAND gate, you have added another NOT gate again with the help of NAND gate, and this structure will be equal to AND gate. Similarly, you can make OR gate as well, and obviously NOR gate if you want. So let's move forward. This is the circuitry or the combination of NAND gate, due to which the combination will start acting as exclusive OR gate, and this is the combination. If you make a combination circuit like this with the help of NAND gate, this structure will start behaving like a exclusive NOR gate. So before going forward to this circuit, let me clear you some concepts about exclusive OR gate and exclusive NOR. So this is the structure for exclusive OR gate, and this is the structure for exclusive NOR gate. I guess so. This should not be here, and this dot should be here, because this is NOR, and this O indicates it is negative. NOT gate is added, and exclusive NOR gate contains this NOT. This is the symbol for exclusive OR gate. This is the symbol for exclusive NOR gate. And talking about its expression, logic expression, this is equals to A plus and circle. This is A and plus circle and B. This is equals to A dot B bar plus A bar dot B. This expression is for exclusive OR gate, and this expression this plus symbol and then circle indicate that this is equal to this expression, A dot B bar plus A bar dot B. And NOR gate is simply, exclusive NOR gate is simply the invert of exclusive OR gate. So you simply have to add a NOT gate or invert the output. So I have added a bar on it. If you will solve this, it will be equal to A dot B plus A bar dot B bar. Okay. Probably you have the idea of how you can solve the logical expressions. These are some important formulas that you must know. AND is equals to A dot B. This is the formula for AND gate. OR gate, A plus B. NOT gate, it is represented by A and bar on it, indicating that you need to invert it. Then these are very important formulas. A plus B whole bar is equals to A bar, and plus is changed to multiplier, or is changed to AND when you have a bar on plus. And similarly B bar. So similarly, if you have A dot B whole bar, it will be equal to A bar, and dot will be changed to plus because of this bar on this dot. So dot bar is changed to plus, and plus bar is changed to dot. So that is the thing that you need to remember. And these two formulas specifically are called De Morgan's law in Boolean algebra. Though I have talked about the IC before, the IC will be 14 pin IC, and there will be a notch, and the numbering of the IC will start from left of this notch. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 will be here and 1 will be here. And numbering goes like this. And 7 pin will be ground, and 14 pin will be given 5 volt. You must watch the previous video, or you must have completed all previous labs. I am skipping minor details that I have already told you in previous labs. So this is the IC. This is the IC, and each IC contains 4 gates. This is the IC for NAND gate. It's better to always search the number on the web to check its pin out. What is pin out? Pin out means which pin indicate which things, or which pin indicate what pin. Is this pin for input, or this pin for output, and what is the configuration of the gate inside the IC. For example, first NAND gate is between first 3 pins. Similarly, second would be another 4, 5, 6, these 3 pins. But what is its configuration? Are 5 and 6 inputs and 4 output, or are 4 and 5 inputs and 6 is output? Like, is it like this, or is it like this? You need to check it on the web, and you must include it in the manual as well, obviously. Okay, so yes, so there are 4 gates: 1, 2, then 3 and 4, and these 2 pins are for powering up the IC so that gates start working. Otherwise, gate won't work if the IC is not given power. Obviously, there is a circuitry inside it containing diodes and transistors that too need biasing for its proper working. So this will be NAND IC, and you will be using this NAND IC to make exclusive OR gate and exclusive NOR gate. So this circuit should be made with only one IC. Why? Because one IC has 4 gates, and this circuit too needs 4 gates. So you need one NAND IC with all 4 working gates. It is quite possible that some of these gates are not working. Why? Because probably some of the students have given it more than 5 watts to the inputs, and its input and the gate will be like will stop working. So it is always better to check the working of the gates first before making the whole circuit. Okay, so probably I have cleared all the concepts. So what you will do? So similarly, what you will do? You will use, let's say, this gate. You will give. You will start with this gate, and then you will connect this input with the input of other NAND gate. For example, what you will do is, you will, if this is the configuration for other gate, what you will do is, you have selected this as an input, and you will connect A. If this is A, if this is B, you will connect A with the input of other NAND gate like this. Similarly, you will connect B with the input of any other, like there will be other gate here as well, or if you are using another IC, you can connect it with it. Like, you have to make this circuit, and you will make it easily if you know like basic electrical engineering or how to make a simple circuit on breadboard, and it's quite easy. And obviously, to show the output, there will be LED which will obviously turn on if the output is 1, and it will turn off if the output is 0. So let's start building the circuit. Okay, so I have built the circuit. It is built in the same way that I've built in the last video, and last video was a bit detailed. So it's better to watch the previous video or to complete the previous labs before making or starting with this lab. Again, I have provided this whole row positive, positive, and this the whole row beneath beneath this row 0 volt. So this whole row is let me have something to point it out. So this whole row is positive. It is given 5 volts. It is at 5 volt potential, and this whole row is at 0 potential. So whenever I will be needing 1, I will simply take out the connection from here, and whenever I will be needing 0, I will simply take out the connection from here. So I have used 2 ICs. I can make this circuit. I have made the circuit for exclusive OR gate, which I have already told you that I can make that circuit with only one IC as well, but the circuit would become so complex, and I would not be able to clarify different connections then. So therefore I've used 2 ICs. You can obviously use 2 ICs as well. Fair. So I've used 2 ICs. First I've given both ICs its power, 14 pin power, 7 pin ground. Similarly 14 pin power, 7 pin ground. And then I've used pull down resistors here, and why I've used it I've told you in the previous lab. And then again, like circuit is built in the same way. Output of first A is first input is given as an input to second gate. Similarly, the B input is given to the third gate as an input, and then output of the third gate is given to the last gate. And I've used 3 gates of this IC and 4th gate from this IC to make exclusive OR gate. Let's make things easier for you. So I have used these 3 gates from this IC and the final gate from this IC, this one. So 2 ICs, these 3 gates from first IC and this one for the second IC, and connections are made like this, except the pull down resistor here and LED here in combination with a resistor. So let's try it out. And I've given 5 volts here. Why? Because I needed 5 volt. I don't need a variable power supply, because I could have used this, but for that I need to set it to 5 volts first. But this supply is already giving me fixed 5 volts, therefore I've used this. So let's start. Okay, so these two are inputs, this one and this one, and currently both are at 0 because of this pull down resistor, and for that purpose obviously pull down resistor was used. If you have not given it any input, it will be automatically pulled down, it will be on 0 0 position. Both the inputs are on 0 0 and LED is not glowing. Let's move an exclusive OR table. So what does it say? If both are 0 0, it must not turn on. Similarly, if both are at 1 1, still it should not give the output, or it should not give 1 as output. It will only turn on if any of the one input is 1 and other is 0. So let's try. So I'm giving A. See, I simply need to insert this in first row. Now A is at 1 and B is at 0, or I can give 0 by connecting it to the other row with the other row. Now this one, A is at 1, B is at 0, and you can see that you are getting output, you are getting 1 as an output. Similarly, if you give 0 0, no output. If you give both inputs 1 1, still you will not be getting any output. Now let's give other input 1 and second one 0, and so it's giving you 0, it's giving you 1. So this circuit was for exclusive OR gate. Similarly, second task would be to make this circuit, and again here you need 1 2 3 4 5 NAND gates, and obviously you need 5 gates and 2 ICs, because 2 ICs contain 8 gates. So it could have been made with the help of 1 IC only, but it must need 2 IC, because 1 IC contains 4 gates and this circuit needs 5 gates. I'm not making it, I'm leaving it up to you. Obviously you need to do something on yourself to learn. This was all about it. Meet you in the lab or maybe in the next video. Until then, Allah Hafiz.